Recording in progress.
Okay, recording in progress. We're getting started, guys. Okay, so let's get moving so we have some more time to get homework done and more free time during the weekend. Okay, so this is, guys, quiet. Thanks. So this is a recap of the 4-5 day 1 notes. We're doing 4-5 over 3 days. We're going to do 4-5 day 2 today, 4-5 day 3 we'll do on Monday, and maybe Wednesday might just kind of just say, let's just look at 4-5 one more time. Make sure you guys understand graphs of sine and cosine. We're not going to do graphs of tangent, cotangent, cosecant, and secant. Those are a little complicated. Even sine, cosine, I'm going to keep pretty straightforward. I'm not going to do all these crazy shifts. So really kind of keep it just like up, down, maybe horizontal stretches or vertical stretches, or flip over the x-axis. So we'll keep it pretty straightforward. So day 1, we just went over the basics of sine and cosine. So here's the table for a sine curve. So it's just like XY table. That's really what it is, right? These are the x values, which are the angles that you plug into the sine function. These are the y values, the output of the sine function. Now, if you guys let me zoom here, just going to draw on the board, but that doesn't make any sense. So if I do a makeshift unit circle right in the corner here, you guys should know that this is 0 radians. That's pi over 2 radians. That's pi radians. That's 3 pi over 2. And it's back to 2 pi. The coordinates you guys should know, this right here is 1, 0. This right here is 0, 1. This right here is negative 1, 0. And finally, this right here is 0, negative 1. So what you're doing is that when you generate a sine curve, you want the y coordinates on the unit circle to be the output for the sine curve, right? So at 0, the y coordinate is 0. At pi over 2, the y coordinate is 1. At pi, the y coordinate is 0. At 3 pi over 2, the y coordinate is negative 1. And 2 pi repeats. These are repetitive curves, right? They have patterns. So we call them cyclical or periodic functions, but they repeat themselves after a certain time has passed, right? It's kind of like we have, say, 5-minute periods at 4 times a day, right? 3 times a day. That's what's happening here, right? The length of one cycle would be 2 pi because it's basically covered the whole unit circle, right? So you cover all possible sine values by the time you get to 2 pi. And obviously, all these x coordinates are on the axes, either positive x, negative x, positive y, negative. Okay, so that's what we did the other day. Now, domain range. Domain's gonna be all real numbers. You can do whatever you want. There's no restriction. That's why this goes on forever. The range is limited, though. You can't go more than 1 or less than 1 unless you multiply sine by some number to the left. Then you amplify the graph, then it becomes higher or lower. 5 key points. Usually, not usually, we do. We always have 5 key points. So I would say this is key point 1, 2, 3, 4. And I know it's a little messy. Let me move that unit circle elsewhere. Give me 1 sec. Erase. There we go. Yeah, so you have 5 key points. So Maggie, can you stop talking, please? Thanks. Awesome. All right. So 1, 2, 3, 4, 5, right? So middle, high, middle, low, middle. Those things look like that. So the middles are the intercepts. You see here. The high obviously the max, and then so that's how you do a sine curve. Sine curves are always going to start at the origin, unless if you shift it horizontally, which we're not going to do in this class. So for the sake of this class, our sine's always going to start at the origin. Always starts at the origin. But it could open down instead of opening up, depending on what a is. If it's positive or negative, we'll get to that in just a bit. Some of the things I talked about was what to and I have a recording of this video. Obviously, you could watch a recording. You don't have to rush. And same thing, Taylor, you could watch a recording from day 1. I have it in Schoology. So, but sine again, you just get the values from the unit circles. It's the y coordinates. Cycle is 1 revolution. The period is the length of 1 cycle, which is 2 pi. The amplitude is basically from the middle of the graph to the peak, or middle of the graph to the bottom, or you can take the high and low, take the distance between them and divide by 2. So if you max y minus min y divided by 2, that could be your amplitude as well. And then we did cosine. And cosine, just, it's the unit circle again. If you look at the unit circle again, now you take an x coordinates from the unit circle. So I take an x coordinate x0, x coordinate pi, x coordinate pi. So that's how you generate the cosine curve. So it's just like the sine curve, just shifted by 90 degrees, as it should be, because cosine stands for the complement of sine. Cycle still the same, still 2 pi long. Domain range still the same. You still want 5 key points. However, the first key point is not on the origin. It's at the peak. And then you have 2 x-intercepts over here. The third point is going to be down below. And then the last point is going to be back to the peak, because it has to repeat itself, right? So yeah, you have 2 x-intercepts. You have 2 maxes, mins. Looks the same, just shifted. That's all. And then we talked about cosine's x coordinates in the unit circle. Periodic function means something that repeats itself. If you decompose the equation, or if you look at the equation and look at the coefficients, A represents the amplitude, the number you're multiplying. B represents a period. It doesn't represent a period, I take it back. B impacts a period. The period's 2 pi over B. That's because 2 pi is 1 revolution. So B is 1, is 2 pi, the period. But if B is bigger, the period gets smaller. If B is less than 1, the period gets longer. If we go to Desmos really quickly, Desmos is your best friend here. You can see that we have sine x, right? And see how it follows these points, 0, 0, pi over 2, 1, pi, 0, 3 pi over 2, -1, 2 pi, 0. What if I put a number like 2 out in front? What is that going to do to the graph? If I put 2 out in front.
It's gonna make,
Yep, it amplifies. It's kind of like a sound wave, right? It gets louder, right? But if I put a negative, see, it flips. Or if I put -2, it flips, but also gets amplified. What if I put a 2 out here? More frequent. Yeah, exactly. The frequency gets higher, or 4, or 10. But if I do 0.5, the wavelength gets longer. So the period is longer for sure. Not as frequent. If you're ever curious how to change the settings on Desmos, you can actually click on that little monkey wrench in the top right corner. You could choose how, say, to go start at -2 pi, just type in pi for pi, and go to 2 pi, and you could choose like how you want the intervals. Like, what if I want my intervals at pi over 4? You can do that, or pi over 8. Usually pi over 2 is standard. So you can choose how you want to impact, because sometimes when it's just integers, it's hard to read it. It's nice when you actually do the x-axis in terms of pi. It becomes easier to interpret the graph. More on this stuff. We do graphs. So the amplitude is 3. So you go to peak of 3, a low point -3. Period's 2 pi because B is 1. So you start 0, end at 2 pi. It's kind of like we start this class at 10 o'clock. We end at 11:15 because we have 75-minute periods, right? Cosine start at the peak. Unless it's negative for A, then you start at the bottom. And period in this case is pi. So you go from 0 to pi. And you have 5 points, right? 1, 2, 3, 4, 5. So we'll talk about construction of the graphs again today, because I think you guys need to see that. Personally, I would much prefer that you guys have a coordinate plane with nothing labeled and you make your labels. Because what if your period is like something weird like pi over 3? Then having predetermined x coordinates on the axis kind of makes it a little tricky. It's good to actually have you customize your own. So we're going to talk about that with some of the other problems. Actually, let's talk about now homework number 7. So I didn't like some of the questions here. Like, I was not happy with number 2. And so here's the reason why I wasn't happy about it. The amplitude's 1. The period, remember, period's 2 pi over B. What's B in this problem here? So the period's 2 pi over 3. That's kind of crappy because look at the labels again. So you can do anything in terms of surface, right? So that's why I'd rather do something blank and you make your own labels. See, if I were to make my own label for this one, I would deliberately put 2 pi over 3 somewhere off in the under, somewhere out here, right? And that'd be 0. Now, what you need to do is you need 5 key points. That's where I start. That's where I end. So that there's 2 points covered. How many more points do I need? 3 more. And they got to be chopped up equally. You got to space them out equally from 0 to 2 pi. 2 pi over 3, sorry. So you have one right in the middle. What do you think that's going to be? The one right in the middle. Just using some proportional reasoning. You have 0 and 2 pi over 3. What's right halfway between? What do you guys think?
1 pi or pi over 3.
Good. Thank you, Eric. Pi over 3. And now the other ones here are a little more, I don't want to say painful, but just not as simple. But it is pi over 6 because, good job, Eric. One way you could do, I'm not sure if Eric was thinking this, but 2 pi over 3 is 4 pi over 6. Yeah. So you break in the quarters, pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6. You could do that. To be honest with you, I don't really care if you come up with the numbers here. What I care about is that you just at least put 3 tick marks or equal space. When you put the numbers next to them, I don't really care. Just show me where it starts and ends, and I assume that you know that these are equally spaced. So I don't care if you put a pi over 3. It doesn't matter. What does matter is that you plot it correctly. So obviously it has an amplitude of 1. So it hits a peak of 1 and a low point of -1, right? So cosine starts at the peak, and then you just go middle, low, middle, peak. Always looks like that. However, sine, which is going to be down here, look at number 3. So does number 2 make sense? How I did that one? Yes. Yeah, and again, these were just kind of crazy. I don't know why they did that. You're probably better off customizing your own coordinate plane. Just drawing x, y axes and just labeling the x-axis yourself. Now, what's the amplitude here for number 3? 2. What's the period gonna be for that one? What do you guys think? B is 1/2, by the way. If B is 1/2, what's my period gonna be? Good, 4 pi. So that means that it's going to start here and end here. And sine starts at the origin. Now you need 3 equally spaced points. Fortunately, those are labeled for us. That's easy, right? You go from 0 to 4 pi, pi, 2 pi, 3 pi, right in the middle. And you go here. Now what's the amplitude here again? So you got to go up to 2, down to the middle, down to -2, back to the middle. There you go. There's the curve. Now, of course, use Desmos or use graphic calculus. Desmos is probably easier because I think graphic calculus is kind of painful with adjusting the axes. So, Maggie, please. Okay. Thanks. All right. Okay. I know I pick on you, but yeah.
No, totally.
All right, I will then. All right. Anyway, the answers are here, so let's keep moving. All right, so I'm done doing a recap and a homework review. Let's now move on to the next set of notes. So you guys should have this packet. It's also electronic. We're going to move on to where it says 4.5 part 2. 4.5 part 2, which is the 3rd sheet or 5th page of these notes. This should take about 15-20 minutes after we finish. You guys need to check in homework number 7. And then do homework number 8 after that. Okay.
It's not on here.
Oh, it's not? Oh. Oh, you know what? I only put part 1 then. That's probably why. Let me pause the video. Hold on a sec. All right. So let's start day 2 of 4.5. Okay. Thanks. Quiet down. All right. So a lot of this is still more review of the same stuff. So it's nothing too new, just more practice than just graphing sine, cosine. And I'm not going to do any vertical shifts. I'll save that for Monday. So again, we're just going to change the period, change the amplitude, and maybe flip the graph over the x-axis. Also, we're going to work backwards, where I'll give you information about the graph or show you the graph, and you got to write the equation from that. But we'll start with things that we've done already. Remember, generally speaking, y equals a times sine bx is a general formula for sine, or y equals a times cosine bx. Remember, the amplitude is a, actually technically it's absolute value of a. The period is 2 pi over b. So b impacts the period. B is not the period, but it impacts the period. B is 1, you assume 2 pi, that's 1 revolution. But if b is a bigger number than 1, then the period is shorter because it's more frequent. If b is less than 1, between 0 and 1, then it's going to be longer period, so it's not as frequent. What's the amplitude for number 1? What would you guys say? 4. Even though you see a negative, we're going to say 4 instead.
The graph will still be flipped though, right?
Yes, absolutely. With the negative, we'll flip over.
So would that mean at x equals 0 will it be -4?
No, it'll still be at 0. It's the second point. The second point will be. How about the period? What's the period here, guys?
2 pi over 5.
Right. And you can see that graphing that in the given plane is not going to be fun because they already label it. Because A is material. Actually, no, that's I probably should do like little. There we go. Maybe that helps because A is negative. You're welcome. How about example 2? What's my amplitude?
2.
And how about my period?
Pi.
That'll be pi. Yep. So let's graph example 2 in the plane below, because that's probably a little more proper to use the plane below for the second example, because given that the period is pi. So when the period is pi, I'm going to start. Where am I going to start it? X equals 0, right? Where am I going to end it? At x equals pi. It's kind of like this class started at 10 o'clock, ends at 11:15, right? Because we're 75-minute periods, right? So we're going to start at 0, end at pi. And because it's cosine, cosine generally looks like this, right?
Yeah.
X equals pi means that's where I'm going to end the graph. So I'm going to start it at 2 for y. So I'm going to start right here and end it right here. Why am I starting it at 0? Sorry, why am I starting at 0.2? We'll plug in 0. What's 2 times 0? What's cosine of 0? The circle. Cosine of 0 is 1. It's usually a circle, don't worry.
0.
No, it's because the x coordinate is 1. But again, you get to just switch, don't worry about it. Now what's 2 times 1? 2. That's where you start 0.2. If I plug in pi, that's 2 pi. Cosine of 2 pi is also 1. 2 times 1 is 2. So this makes sense from a unit circle perspective that these coordinates are in the right place. Now, how am I starting? Well, I'm ending. That's 1 cycle. But I need 3 equally spaced in the middle. So if I need 3 equally spaced in the middle, I'm going to do this. Here, here, and here. So remember, high, middle, low, middle, high. So for cosine, I'll have to write over here. For cosine, high, it's not a parabola. It's like one, but a parabola has a much different.
But not
As a calculus teacher, that is quite egregious. But you guys have non-calculus yet? Don't worry, you're pre-calculus. But I won't say it upsets me. It bugs me. It bugs me. It's okay. I'm just being a math geek. It's not proper. Yeah. So it's kind of like the I me thing in English class when you say like my friend and me went to the park. Like that's terrible. My friend and I, or like my friend invited my parents and me to go to the park. Like
people have bad grammar. Everyone always fixes me, and I hate people fix my grammar. Like
I would say punctuation is probably my biggest pet peeve. But
like you say there in the text, and they go there. Like, I don't need you to fix my name. You know what I was trying to say.
Exactly. There we go.
Theirs are like, I will fix your name.
Or yours another one. Your, yeah. But you want, yeah, but if you do want to be effective with your communication, get it out quickly, yeah, then who cares? Yeah, who cares? But it could hurt you on the ACT or SAT. Anyway, but those are easy to fix.
Yeah.
Okay, so there's a curve. Okay, so that's the second example. Let's move on. So it's high, middle, low, middle, high for cosine. Now for sine, I'm gonna go ahead and erase some stuff here. Any space. Okay, I'll do the sine curve down here. So we're going to 2 pi over 5. And we're starting at 0. The amplitude was 4. So high point of 4, low point of negative 4. So we're always going to start it at the origin and end it at the on the x-axis. So because think about it, if I do 0, 5 times 0 is 0. What sine is 0? The y coordinate is at 0 radius 0. And negative 4 times 0 is 0. So it should be 0. But plugging 2 pi over 5, 5 times 2 pi over 5 is 10 pi over 5. 2 pi. Sine 2 pi is 0. Negative 4 times 0. So I got that taken care of. You need 3 in the middle equally spaced. You need 3 in the middle that are equally spaced. So I need to have 1 here, 1 here, and 1 here. If you want to label it, go ahead. I don't care. I know it's pi over 5 because halfway between 0 and 2 pi over 5. Or if you so desire, you could change this one to 4 pi over 10 if you want. Because then you'd have 5 over 10, 2 pi over 10, 3 pi over 10, 4 pi over 10. I don't care. You don't need to do that. But you do need those 3 equally spaced tick marks. And then it goes like this. It goes middle, high, middle, low, middle. That's what sine does. So I need a high, a middle, a low. And there's your curve. That's it. Not that hard. 5 key points. 1, 2, 3, 4, 5. Middle, high, middle, low, middle. So 3 x-intercepts, peak, low point. Plus, if you're plugging pi over 10 here, then that's pi over 10. That becomes 5 pi over 2 is pi over 2. Sine pi over 2 is 1. Negative 4 times 1. Oh, I messed up. I made a mistake. What mistake did I make? I messed up. I didn't flip it. Thank you, Big Connor. Good looking out. I forgot to flip. So sorry. Oh, cool. Thanks. All right, okay. So yeah, that. Yes. Yeah, that's actually switched. Yeah, he swapped because A is negative. My bad. And then, so how did I, guys, quiet down. How did I catch myself? Because again, like I've done this for 20 plus years. I made a mistake.
Would you give yourself partial credit?
I would. Well, actually, no, I would get full credit.
I would give you full credit.
Because I would catch my mistake if I turn it in. Because look, pi over 10. I knew this pi over 10. When I plugged it in, I stopped myself in my tracks. Like, wait one second. That sine of 5 pi is 1. Oops, that's negative 4, not positive 4. I had it at 0, I had it at 4 over here, so I knew I had to flip it. So I was able to stop myself before I went any further. So yeah, so checking your work is good, right? All right, this is a kind of drill and kill. Just to make sure you guys are comfortable with identifying amplitudes and periods. Remember, that's just the absolute value of A. Remember, that's just 2 pi over B. And generally speaking, y equals A times sine bx, or y equals A times cosine bx. So I'll do the first one. The amplitude's 1. The period is pi over 4. So pi over 2. Wow. I should know that. Because B was 4. Okay. I'll give you guys a couple minutes to do B through H. So do the other 7 really fast, check each other. I'll come up in about 2 minutes from now. Actually, probably don't need that much time.
Can we keep going after we finish them?
I'll put it in a sec.
Yes, sir.
Yes, sir.
There's some fun.
Yeah, go ahead. All right, let me put up the answers. So 1, 4. By the way, if A is negative, you don't report the amplitude as negative. Always report the amplitude as a positive value. Even though the negative would indicate flip, you should do that, which I forgot to do in example 1. But always report A as positive, just so you know. And then period should be easy. 2 pi over 5. 2 pi. 2 pi. Pi over 2 again. I'll come back to that one in a sec. That's pi. That's pi over 3. This one's going to be 3 pi. Because if you think about it, you're doing 2 pi over 2/3, which is 2 pi times 3/2, which is 6 pi over 2, which is 3 pi. So just be comfortable with the fractions. If you're doing a fraction, multiply by its reciprocal. You flip the bottom fraction, multiply. So questions on these? We're okay? We're cool? Okay, cool. Eric, are you on your phone?
Oh, sorry.
Yeah, thanks. Okay, all right, cool. All right, let's keep moving. All right. More, just the same stuff. We have 6 graphs we'll do. We'll work backwards and then we're done. You guys can do checking after that. All right. Okay, amplitude. Let's do both of these simultaneously, just so we get this quickly. So A is 3 here. A is 2 here. B is 1 here. B is 1 here. So the period is 2 pi, and the period is 2 pi. One, 2, 3. -1, -2, -3. 1, 2, -1, -2. Okay, sine. We're going to start at x equals 0 and
We're always gonna have like.
Yeah. Yep. And then start here at the origin, end here at the x-axis, high, middle, low. That's it. But cosine is going to start at the peak, and at the peak, middle, low, middle. Okay, so that's how. And cosine also starts at x equals 0. And ends at 2 pi. Again, plug in 0. Cosine 0 is 1. 2 times 1 is 2. Pi over 2, cosine pi over 2 is 0. 2 times 0 is 0. And so forth. So it's just like using your unit circle. So it's an extension of the unit circle. Questions on A or B? We're good? Okay. Let me kind of set up the ones down below, then I'll move the screen just a sec. A, 4, B, 2, A, 3, B, 2. Period for each of these are what? For C and D. Yep, thank you, Diana. Pi, you got it. 2 pi over 2, which is pi. Yep. 2 pi over 2, same thing. Okie dokie, amplitudes we got. We're doing sine cosine again. All right, let me move the screen. Let me erase the other junk. Just lasso all this. Okay, let's. That's. All right, that's nice. There we go. Okay. So sine, we're going to start. We have 1, 2, 3. 1, 2, 3, 4. 1, 2, 3. 1, 2, 3, 4. you don't have to label the other points. If you, I mean, the tick marks, I don't care. You start at the origin for sine. Now, the period's pi, you're gonna end here. So we're gonna start at x equals 0, end at x equals pi. Oops, I'll do cosine just a little bit. Okay, now very important. You have to have 3 points in the middle, right? So I'm gonna do this and do my graph. Where would the second point be? What would be the y-core of the second point for sine? But how about the y-coordinate? Be high, yeah, high, because we didn't flip. Then middle, low, middle. That's sine. Cosine starts at the peak. If you plug in 0, cosine of 0 is 1. 4 times 1 is 4. And we end here. So we need to do this. High, middle, low, middle, high. And they are the same graph. If I just graph more cycles, they look the same, but yeah. So questions? I know, not terribly the most exciting stuff. The problems will get more stimulating down the road. Yeah, go ahead. No, you don't have to. Not required. I mean, if it helps you. Yeah. Okay, let's keep on moving. Yeah. All right. Okay. A is 2. B is 2. My period is going to be pi. A is 1. B is 4. Period is going to be pi over 2. So you start getting faster with this, right? Because you know 2 pi over 2 is a formula now. Because 2 pi is one revolution, but the d impact the period. So 2 pi over 4 is pi over 2. 2 pi over 2 is pi. The other amplitude is 1 and 2 respectively. Yeah. Cosine is going to start at the peak with an amplitude of 1. Sine is going to have amplitude of 2. Yes, and cosine starts at the peak. Actually, they each have different ending points. Yeah, this one is going to end at x equals pi. This one's going to end at x equals pi over 2. So for the cosine graph, that's going to be really tight. Yeah. Really, really tight. So see, that's why I'd rather give you a blank. Or so you can put pi over 2 like way off to the right, so you can give yourself enough space. See, it's very confined to because it's predetermined x coordinates. So it's from 0 to pi over 2. So you have 5 points, you have to be in the middle of it, right? If you want to label it, it's like pi over 4, pi over 8, whatever. So you're gonna have this. I'll do green. Looks like that. Let me get my. Okay. For sine, it's going to start at the origin, end at the origin, so end at the x-axis, and you have 3 key points in the middle. So it's going to look like this: here, then to the peak, middle, low, middle. Yeah. Okay. Cool. It's good. Yeah. Great. Oh, hold on. Sorry. Okay.
When you call 0 the origin, you feel like
I don't know. This is a really weird question. Sure. Yeah, maybe. Yeah, yeah, okay. All right. You're starting to get me, Teo. All right. Okay. Last one. Last couple. Okay.
Oh, guys, 2 more left.
No, it's a weird question, but okay. So again, this is the general formulas we're having for sine and cosine, right? And remember, amplitude is A. The period is 2 pi over B. So this shouldn't be too bad then. Y equals 4 times sine. And what's going to be the B value for number 3? What do you guys think?
2.
Good, it's 2. Yeah, because 2 pi over B equals pi. So 2 pi equals pi times B. So B is 2 pi over pi. So be a little bit drawn out, obviously, off to the left. But if you're having a hard time seeing why it's 2, you could do the algebra there. But if you just think intuitively, yeah, if I have 2 pi over B and 1 period pi, B has to be 2 to get my pi. So that's going to be that right there. 4 sine 2x would yield an amplitude of 4 and a period of pi. Okay, next up, y equals 5 times cosine, because A is going to be 5 here. Well, what's B going to be for this one?
0.5.
Yeah, 0.5 or 1/2. Now let's how did Teo get that? Okay, so 2 pi equals 4 pi B. So B has to be 1/2. Make that work. Or you could write it like this, x over 2. Same thing. Or you could do 0.5, I don't care. It's up to you. So the homework number 8, is gonna be a lot of stuff like this, where you're given the graph and you have to write the equation. So it's just kind of reinforcing amplitude and period, all that stuff, right? There's also one set of questions that involves matching, which should be pretty straightforward. So the homework, you guys should these knocked out before grade lunch. The homework check-in. Any questions? We're good? Okay. So let me stop the recording.